Okay, so if you have a whole number like this, or integer, actually an integer because it's negative, right? You could put it over 1 to think about its reciprocal. So the multiplicative inverse then would have been 1 over negative 152. Okay? Additive inverse, opposite, negative 2/7. And reciprocal or multiplicative inverse, flip it, positive 7/2. Okay, so try to figure out what property is being shown here. I usually look at the left side of the equation and then the right side and see what's different. And all they did was change the order, right? So the property that changes order for addition would have been commutative. You can just, and the plus means addition. Okay? Number 4, they took the pi that's out front and they multiplied it by both terms inside. So that's distributed. So if you have a problem similar to one of these, which you will on the quiz Friday, our first quiz will be Friday, if you're using commutative property or associative property, if that's what you think it is, or that's actually what you know it is, right? Put addition or multiplication, depending what operations there are. Okay, distributive, you don't have to put it, because it's going to have multiplication and addition in it, or multiplication and subtraction in it. Okay, mental math, just thinking through this, since we're trying to find 15%, what should we do first or think about first? 10%, right? That's real easy, and that's all that is moving the decimal point over 1, right? So that'd be $6.42. So how do I get from 10% to 15%? So I know what 10% is. It's $6.42. How would I get 5%? Abigail? Divide by 2, is that what you said? Yeah. Split it in half. So that's what? 321? So then I could do what with those two answers to figure out the 15%? Add them together, right? Again, if you actually have one of these problems, you won't have one of these on the quiz. Okay? But if you were, you could just go 0.15 times $64.20, right? But that's 963? But you wouldn't really need a calculator. You could do it using this calculator, right? All right, so good warm-up. Any questions? Something didn't make sense? Yes, Macy?
What was the answer you wanted to know?
Okay, number 1. I didn't write them down, but I can do that. All right, so the additive would be the opposite, positive. And multiplicative would be the inverse, or multiplicative inverse would be the reciprocal. So we just flip it.
The number 3, is that a P or a plus sign?
That's a plus.
What is the plus sign?
Addition. What operation's being used in that problem? So for commutative property or associative, you're going to have to add to it addition or multiplication to get full credit. You probably have one of those. Probably on the quiz, it's going to be commutative, associative, or distributive. Probably, if I remember right. All right. So just going over the homework real quick, and then again, if you have questions, ask. You guys have done a really good job of asking if you're not sure about something. Number 15, the additive inverse would be positive 2.5. And the multiplicative inverse would be negative 2/5. Because you can think of that as negative, the fraction for negative 2.5 is negative 5/2, so you just split it then. Number 18 is positive 2/3 for the additive inverse and negative 3/2 for the multiplicative inverse. Any questions on that too? Okay, 21, what property is being demonstrated there? They just multiplied the z out front by the x and the y, so that's the distributive property. For 24, it said to use mental math, and when you do that, you should get $13.50. But again, if you were to just use your calculator, you could just go 0.09 times 150. 27 is never true. When you multiply inverses, you get 1. It should have been 1, then it would have been always true. Number 30 is $50.97 to the nearest cent. For 33, it was 2 loops. For 36, it was the commutative property of addition, like this one. 39 is the multiplicative inverse property. 5/4 would have been the answer. I'm sorry, 36 had 11/15 x was what you should have written as well. And for 39, 5/4 in the blank and multiplicative inverse property. 42 is $139. And 45 was the multiplicative identity property. Just multiplying by 1, you get the same thing back, same number. Any of those you'd like to go over, not sure about? Yes, great.
39.
39. So we got 4/5 times what equals 1. Okay, we could do it like an equation, right? Just put x in, what we're looking for. So what do I do with that 4/5 to move it to the other side to get x alone? You could divide by 4/5, or what I like to do with fractions is multiply by the reciprocal. That's like dividing. That would give me x is 5/4. That's how I would fill in the blank. Okay? And what we talked about last week with multiplication, number 1 was the multiplicative identity. So if I'm multiplying a number by another number and the answer is 1, those two numbers are multiplicative inverses. So we would say that's a multiplicative inverse property. Hannah, did you have a question? Did you have your hand up?
No.
Okay. Autumn?
45.
45. Okay, 10c times 1 equals 10c. So we were supposed to say what property is being represented there. And anything times 1 is itself. You just basically drop the parentheses, but they're just multiplying by 1. So that's the multiplicative identity property. Just like if I add 0, I get the same thing back. That would be the additive identity property, adding 0. But multiplying by 1 gives me the same thing. Yes, Macy?
42.
42 The base price for an airplane ticket from Austin to Houston is $185. So kind of write down. I kind of write everything out from the information they give us and then try to figure out what they want. The final price includes an additional $16 for airport fees. You know, additional, so added on, right, plus. And $12 fuel surcharge. So additional $12 there. Jose purchased a ticket online 40% off the base price. Explain how to use mental math to find Jose's final price to the nearest dollar. Okay. So 40% off. I would do 10%. Would have been $1 or $18.50. Sorry. Here's a decimal point, right? So 10%. You move it over.
Why did you do that for low 85 and not like the total of all?
Because that was the base price.
Okay.
It said 40% off the base, right? Yeah. Right, 40% off the base. So that's why I did it there. So then I need 4 of those, right? So, you know, you can do 4 times 18. 4 times 5 is 20, right? And then 4 times 8 is 32, and carry, try and do it in my head and write it down at the same time. You know, if I'm doing this, is what I'm doing. So 20, and then 8, 32, and that's $72 off, right? So what do I do with the 72 since it's off? I subtract it, right? $113 would be explain how to use mental math, final price then. And then we have to add the $28, right? For the extra charges. So 11, 4, 1. So I said 141. What did the book say? 139?
Yeah.
Yeah, I would say it's 141. So what did I do wrong?
Wouldn't you have to carry the 2 over and 20?
Oh, duh. You're right. So 32, that'd been a 34, right? $74. So 111, those are my 39. See, I can't even do mental math anymore. Anything else? So, Macy, you probably tried to do 40% of the total instead of the base, yeah. Okay? Any other questions on that? All right, so today we're going to do some square root stuff. All right? We're going to simplify them, add them, subtract them, multiply and divide them. We're going to rationalize some denominators. So, again, you did this back freshman year in Algebra 1, but we're going to do it again in Algebra 2 to remind us how to do this stuff. All right? So, we won't worry about that warm-up. We'll just get right into it. So, some vocab we're going to be doing. Radical symbol, radicand, principal root, rationalized denominator, like radical terms. So, you know what like terms are, right? Can you add 3x plus 4y? No. Right? They got to be 3x plus 4x or 4y plus 3y. Got to be the same, right? Same thing with radicals. So this is a radical symbol. And the number under that radical symbol is called a Radicand. Okay? It says the radical symbol indicates only the positive square root of a number, called the principal root. Okay, to indicate both positive and negative square roots of a number, you use this plus or minus symbol. You'll see that once in a while. When we solve quadratic equations, by taking the square root of both sides, we'll use that symbol as part of our answer. Okay, so principal square root, it's always positive. If you have a negative out front of your radical sign, your answer is negative. If you have this plus or minus sign out front, you can put that in your answer as well. It just means positive and negative. Because if we get technical, 5 times 5 is positive 25, right? And negative 5 times negative 5 is also positive 25. So if we want to get technical, we should do that every time in our answer, right? Because actually both of those are correct answers. Okay, simple, right? I'm not going to worry too much about, actually I'm not going to quiz you on it either, for estimating value. Okay? Again, the way they do that is they pick two perfect squares between that this number is between. So 4 is a perfect square and 9. So you know that the square root of 4 is 2, and you should know that the square root of 9 is 3. So since the square root of 5 is between those two, that means the square root of 5's answer is between those two numbers. Okay, but again, I'm not going to quiz you on that, test you on that. I know you're just going to use the calculator to figure out what the answer is anyway, right? But that would be about 2.2. 5 is pretty close to 4, not that, further away from 9, so it's going to be closer to 2 than to 3, the answer. So again, they're going to ask you this, 5 is the square root of 20, the square root of 25 is 5, and the square root of 36 is 6, so it's between 5 and 6, that's closer to 5, closer to 25, so it's like a 5.2 answer. All right, and the actual answer would have been 5.2 something. I don't know. If you go to the calculator, just to do it quick. Yeah, it's 5.19, 5.2. Again, you're just going to do what I just did, right? So if you have a problem like that today for homework, you can just use your calculator. What I really want you to do is learn how to simplify radicals and put it in simplest radical form. Okay? So here's a couple properties of square roots. And again, I'm going kind of fast today, so just watch instead of trying to write everything down. You can look back at this if you need to. What I like to do is what I call a factor tree. When I see a number, and I would have broken it up into 4 times 3, but I would circle that 4 because 4 is a perfect square. And I know that the square root of 4 is 2. And all of you know that the square root of 4 is 2, right? So that 2 from the square root of 4 comes out front. And that 3 from the 4 times 3 to 12, that doesn't have a perfect square factor. That stays underneath the radical sign, or stays part of the radicand is what we call it. Okay? Sometimes you'll have 2 radicals. And if it's multiplication, they're not the same. That's okay. You can still multiply them. That gives us 16, and we know the square root of 16 is 4. So you can go both ways if you want, is what they're saying. Okay? You can take 2 radicals and make it 1, or you can turn 1 into 2 and then simplify. Same thing goes with quotient or division. This one's easy because these are already both perfect squares. The square root of 25 is 5, the square root of 16 is 4. Sometimes you'll want to write it like this. Sometimes you might want to split it up. You can go interchange, whatever seems easier for you. Okay, since both of these are under the radical sign, both of those are radicands, I can actually divide them. I would not be able to divide those two. See the difference? Okay, I can't divide 2 into 18 here because it's not under the radical sign, but here, it's okay. Well, that makes it easy. Square root of 9, make it 3. So sometimes you'll want to leave it like this, sometimes you want to split it up like that. Whatever seems easiest for you. Making sense so far? Coming back to you maybe from a couple of years ago? Haven't done this much for a while. So, it says, these properties can be used to combine quantities under the radical symbol or separate them for a purpose of simplifying. Okay? It's in simplest form when the radicand has no perfect square factors left, except for 1, and you cannot have a radical in the denominator. So, no good. No radical in the denominator. Everybody say no good. Oh my goodness. Wake up. Look good, feel good? You are good, right? You guys are good. We got to wake up a little bit. All right, so we're going to simplify this. So do a factor tree. What times what is 32? You should know. You should know. 8 and 4. But I like. It doesn't matter. 8 and 4 is okay. But I like to use 16 and 2. Because, what do I know 16 is? Perfect square, 4 times 4, right? So I can pull the 4 out and leave the 2. But 8 and 4 is okay. I'd stop there. So what's the square root of 4? 2. Square root of that 4? 2. What would be left? 2. What's 2 times 2? 4. You end up at the same place. Okay? Some people were taught by their Algebra 1 teacher to do this. Maybe they even went 16 times 2 to start. And then you went 4 times 4. Let's change the color. And then you were taught, when you see a pair of the same number, to circle them. Anybody learn that way? Okay, that's fine. All right. So for this pair of 2s, what do you pull out? The 2. For that pair of 2s, what do you pull out? Another 2. And then what was left? The 2 up there. So you can do it all 3 ways. I like to try to think of the biggest perfect square that's in there. Okay? To make that work. It's the quickest way. All right? This is an easy one. They're both perfect squares. What's the top going to be? Bottom? Oh, these guys are so smart. Simple, right? Questions? Okay, you could do a factor tree here. Or, what's 3 times 12? Why is 36 nice? Perfect square. Okay? But if you went 4 times 3 there, 2 times 2, you got that 3, and 4 times 3. Right? Then you could go 3, 2 times 2 times 3. What's 2 times 3? You still get the 6, right? Pair of 3s, pair of 2s. Okay? So you can see it. It doesn't matter whatever works for you, whatever you're good at, is fine with me. Can I divide 5 into 500 because they're both under the radical sign? Yes. So what's 5 divided by 500 divided by 5? 100. That's nice. Why? It's another perfect square, right? All right, let's move on to rationalize the denominator. Okay? That's when you have a radical and denominator. Not allowed to have. No good. All right? Like that. All right? So what we do to rationalize is we take this bottom, this denominator, and multiply it by itself over itself. What's anything divided by itself? 1. What's anything times 1?
1.
Itself. So we're basically multiplying by 1. It's going to look different, but anytime you multiply by 1, you're not really changing. Okay? But we're changing that bottom, we're rationalizing. What's 2 times 2? 4. What's the square root of 4? 2. So that's where that 2 comes from. 2 times 2, square root of 4, which brings back the 2. So you get the same one that this basically cancels out the radical sign. And then you got whatever you do to the bottom, you got to do to the top, so you're not changing it. And 5 times 2 is 10. So that'd be 3 radical 10 over 2 when you rationalize the denominator. It's okay now. It's okay to have radicals in the numerator. It's not okay to have radicals in the bottom, the denominator. So we rationalize to fix it up, simplify it. Okay? This one, I would not do that. Here's what the book does, and that's wasting time. Okay? Why is that wasting time? What do you know about these two numbers? They're both under the radical sign. Can you simplify 2/8 to what? 1/4. What's nice about those? They're both perfect squares, aren't they? What's the square root of 1? Square root of 4. Much easier doing that, right? Than doing all this 8 stuff. Okay? And you got to keep going down. Make sense? So try to find the quickest way if you can. But you got to know your multiplication factor. All right. This one with 5 and 7 got anything that goes into them? No. So multiplied by the 7, you got to do that one. 35, 335, and 7. Can I simplify that? Is there a number that goes into 3 and 7? No. So we'd be done. But if these were both even, let's say, then we reduce it. Okay? Always reduce the lowest term. Could I simplify that one? No. 5 goes into both, but if this 5 wasn't in, underneath. So we just have to do the 10 and the 10. Okay? But when we're done, now the 5's out and this 10's out. Now I can do this 5 divided by 5 and that 10 divided by 5. So that's a 1 and a 2. Questions? Hannah, you got a question?
Well, didn't you say they could be in the numerator?
Right, I couldn't. That's why I did the radical 10 over radical 10. And then we got this. 10 times 10 is 100, square root of 100 is 10.
So it just can't, your final answer.
Right, the final answer can't. Right. Yeah, I guess we write it like this so we can get rid of the 2 in the box. Make it 1. Okay, one other thing I got to show you. I know we're running late on time. You got to have common radicals to add and subtract. The top row, I couldn't add or subtract all of those. The bottom row, I couldn't. Could I add those? Yeah. 16. Radical 3. Easy to do. All right? This one I couldn't. But what could I pull out of there? Not a 4. What do you pull out? The square root of 4, which is 2. Now can you subtract them? Yeah, so even though you'll get some problems like this, look like you can't do, you actually can because you got to simplify first. And then you get like radicals. What's 6 minus 2? 4. Okay? So You have a few problems like that as well. All right, I know I went fast because we were short on some time because of pictures, but I got faith in you. The E is for even. 18, 20, 22, 24, 48, 50, 52, 54, 56. Any questions? Hopefully I won't shove it down your throat like that much. Again, if you get stuck, just do the best you can. We'll go over it tomorrow. If you need extra help, email me or find me. I'll help you.